Well, hi there, everybody. I'm going to show you in this little video a method for factoring, specifically just finding the greatest common factor of a polynomial. And I'm going to show you something, maybe you've seen it other places, but I'm going to use this thing called the ladder method. Finding the greatest common factor of a polynomial, for some reason, can be really challenging sometimes for a lot of students. It's just something that they just have a hard time seeing. And so it's useful to have some kind of a little process by which you can take these things, these expressions, and take them apart and look for these factors of these expressions. So I'm going to show you this thing called the ladder method. First, I want to, in case you're unfamiliar with the ladder method, I want to do a little demonstration of how it's frequently used, actually, which is to find the greatest common factor between two or more numbers. So I'm just going to pick a couple of numbers there, 40 and 72, and my goal now is to find the greatest common factor between those two numbers. So I'm a beginning factorer, and I'm not so good at it yet. I can see that both of those numbers are even, and so they have a common factor of 2, but I'm trying to find a larger one. So this ladder method might help me find that. So the ladder method basically it looks kind of like long division, but we draw the little box on the underside of the pair of numbers. And so I'm looking at 40 and 72, and I'm thinking, okay, what a number that goes evenly into both of those? And well, 4 goes into both of those. So if I write the 4 down there on the outside of the ladder, and then I divide each of my numbers by 4, what I get left is 10 and 18. So 40 divided by 4 is 10, and 72 divided by 4 is 18. So now I'm working with the numbers 10 and 18. And the only number that I can think of that goes into both of those is 2. So I'm going to draw another little box underneath those numbers. And now you can see it starts to kind of, that's where this ladder idea comes from, or you know, if this had many steps, it might start to look like a ladder. And I see that 2 goes in evenly into those, and I divide both of them by 2, and I get a 5 and a 9, and that's really as far as I can go, because I just cannot think of any integer that goes in evenly into 5 and 9. So we're done with the factoring. And in fact, what we do now is we take all those numbers that we wrote on the outside of the ladder there, the 4 and the 2, you multiply them together to get 8, and now we have just found that the greatest common factor, the GCF, is 8 between those two numbers. That's the largest number that goes into both of those numbers, 40 and 72. So I'm going to make one little change. I'm going to copy that, basically that whole little pattern down there, this ladder method again. But now I'm going to show you that that method, which is fine for finding the common factor of 2 or 3 or more numbers. You can have many numbers, you know, lined up in a row there. But we can also, instead of a comma between those two numbers, what if I put in a plus sign? So now I've got not just two numbers, but I'm actually adding those two numbers together. Well, I can treat them exactly the same way. 40 plus 72, if I look at a common factor of those, it's a 4, and I write, you know, that's how I got the 10 and the 18 is by dividing. So I'm just using the same numbers. And now what I wanted to show you here is that by doing that exact same process, this ladder method on a sum of numbers, what you've got is a way to actually factor that expression. So I've taken the numbers 40 plus 72, a sum of two numbers, and I've rewritten it as a product of two things. I've written it as 8 times 5 plus 9. And that is what factoring is, taking a sum or a difference of numbers and rewriting it as a product of numbers. So 40 plus 72 is equal to 8 times 5 plus 9. And that's what factoring is. And if you can sort of appreciate how this ladder method worked for that sum of numbers, it's not a big step at all to use this method for an algebraic expression. So let's try that next. I've got I wouldn't call that a really difficult factoring problem if I'm going to try and factor that expression. It's not super easy, but it's kind of a medium easy maybe factoring problem. So I'm going to use the ladder method once again. I'm going to draw a little box underneath the numbers, and I'm going to look for the biggest number that goes into both of those. Well, I'm still kind of a beginner at factoring, and so I can just see that between 16 and 20, a common factor is a 4. So I write the 4 down, and that's about all I can handle in one step here. So let's see, what do I get if I take 16x to the 4th y divided by 4? I get 4x to the 4th y. And the 20 just gets divided by the 4, so now I have 5x squared y squared there. So that was it. I don't have to find the biggest common factor in one step. I can take it in as small a step as I am comfortable with. So right there I was comfortable with dealing with the 4 and not really trying to deal with the variables there and the exponents. But now that's what I got to do, because I can see that each of those terms, as I get better and better at factoring, I can see that there's an x and a y in both of those terms. So I'm going to try this latter method now with my common factor being x times y. And I can see that if I take that first term and divide it by xy, I get 4x to the third, and the y goes away, because y divided by y is just a 1. Then I have plus, and 5x squared y squared, when I divide that by xy, I just get 5xy. Okay, so that was good. I found another common factor there, xy. But I'm not done yet, because I can see that each of those terms still has an x. So let's just divide everything by x. And that gives me 4x squared plus 5y. And I think, okay, am I done yet? Are there any common factors between those two? So I've worked this down to 3 steps, and you can see why it's called the ladder method now, I guess. But I'm done. There's no more common factors between those two terms, 4x squared plus 5y. So now I'm going to rewrite the expression as a product of two things. I'm going to take all of those terms that I found, all of those factors that I found on the outside, I wrote them down there on the outside, write those down, and what's left at the bottom is my other remaining factor. That's what's kind of nice about this method, is that it not only shows you what the greatest common factor is, but it shows you what you get when you divide everything by that common factor. And you can do it in 1 step, 2 steps, 3 steps, whatever is comfortable for you. So this expression that we started with there factors out to 4x squared y times the binomial 4x squared plus 5y. So it's a pretty nice method. What a lot of people would probably end up doing is abandoning this method or shortening it and finding bigger and bigger common factors to make, less work for themselves. But what's really nice is that you can take it at whatever level is comfortable for you until you feel like making it a little bit quicker. Let's do this method for one more, what I would call a pretty challenging factoring problem. And you see this a lot in Algebra 2 classes and things like that. And so each of these terms in this algebraic expression has a binomial factor as part of it. So that really messes with people when they look at that. Their eyes kind of go cross-eyed and they think, oh my God, that is so complicated looking. How can I ever factor that? So it takes a little bit of practice, but you can see that if I try the ladder method with this, it's going to work out just great, because I can see right away that, and I'm going to go for the big one here first, this x squared minus 2 binomial. I'm going to call that my common factor. And if you haven't seen these kinds of expressions before, or you've had trouble factoring them, watch how easy this is now, because when I divide each of those terms by x squared minus 2, what I have left is just the thing that was on the outside of the parentheses, just the other factors there, 5x cubed minus 40x squared y. That's what I got left. And so now I'm just going to factor that as I did the previous example. I'm looking for common factors there. I can see that 5 is a common factor and that x is a common factor. Oh, wait, there's actually 2 x's in each of those. So I can say 5x squared. And I'm getting good at this now. So that's my greatest common factor of those 2 terms there, 5x cubed minus 40x squared y. So I'm going to just use that. When I divide each of those by 5x squared, I get x minus 8y. And there's no common factors between x and 8y, so I'm done now. But what's interesting here is that those things that we have on the outside there, those are my factors of my original expression. I don't want to multiply those together like we did in some of the previous examples. That is, I am going to multiply them, but I don't want to use the distributive property and multiply them together. I'm just going to write them all out, because my other factor there is x minus 8y. And that is my factorization when I just literally write those 3 factors down. And that's factoring a rather complicated expression using this ladder method. I hope you found it useful. Thanks a whole bunch for watching this video. Take care and go do some good math now. Okay, bye-bye.